X to the 1/3 is the same as the cubed root of x. X to the 2/3 could be the cubed root of x squared. That's probably how I would write it. But if you wrote the cubed root of x all squared, that would also be fine. X to the 1/2 is just the square root of x. You can write the 2 as the index if you really want to, but it's unnecessary. This is the square root of x cubed, or if you prefer, you could say it's the square root of x all cubed. Now the x is not affected by that exponent, so this is x times the cubed root of y. In this case, the x is affected by the exponent, so this is the cubed root of xy. Here we're asked to go the other way, so the 4th root of x could be rewritten as x to the 1/4. And the 6th root of x could be rewritten as x to the 1/6. The cubed root of x to the 4th is x to the 4/3. The 4th root of x to the 7th. Well, the 4th root of x is like x to the 1/4. But the 4th root of y to the 7th is y to the 7/4. So they don't have the same power. The square root of x is x to the 1/2. This is the reverse of a problem we did up above. And the square root of xy all cubed says that we should take xy and we should raise it to the power of 3/2. You can write it that way, or you could write each of the individual things with the power of 3/2. I would accept either way. Now we need to simplify each radical. The perfects are easy, right? The square root of 64 is 8. The square root of 100 is 10. The square root of 4/9 is 2/3. The cubed root of 125 is 5. The 5th root of 32 is 2. And the square root of 36 is 6. These we're asked to write in exponential form. So we have x to the 2/3. The 9 is not affected by any of those radicals or the exponents, so there'll be no parentheses. So this is 9 times b to the 3/5. The 27 is, so if we're not simplifying and we are simply rewriting, this is 27 to the 1/3 and x to the 5/3. If you couldn't help yourself and you took the cubed root of 27 and said 3x to the 5/3, I don't think I would mark that wrong because it just feels really wrong not to take that cubed root.